Okay, one more stoichiometry problem because, hey, why not? In this one, we have our question is what mass of carbon dioxide is produced if 100 grams of oxygen is used to burn this C3H8, which is actually propane. So if you have any gas at your house, you may be using this combustion reaction right now where the hydrocarbon propane reacts with the oxygen to burn and give carbon dioxide and water. If you remember, a combustion reaction always has the this sort of format where you have a hydrocarbon burning in the presence of oxygen, giving off carbon dioxide and water. Okay, so back to the actual problem here. It says what mass of the CO2 is produced, and we have 100 grams of oxygen. Okay, so the first thing I need to do in stoichiometry, remember the very first thing I need to do is balance this equation. So I'm balancing this equation. I think I've told you before that a good idea or just a good hint in balancing combustion reactions is to always take the carbons first. In the reactant side, I have 3 carbons. In the product side, I have 1. So this propane, since there's 3 carbons, I could get 3 carbon dioxides out of that. And so that gives me 3 carbons. Now I have 8 hydrogens, and on the product side, there are 2 hydrogens. So from here, I could get 4 water molecules. Now I'm going to look at my oxygens. I have 2 on the reactant side. On the product side, I have 3 times 2 from the carbon dioxide, that's 6, and then the 4 that are in oxygen. So 6 plus 4 is 10. And so if I had 5 of these water molecules, then that means I have 5 oxygen atoms altogether. So the first step is done. I've balanced my equation. Now I'm going to start with setting up the dimensional analysis on this. And so I'm going to start with my given amount, which is 100 grams of oxygen. So I'll start writing here. 100 grams of the O2 is the form that the oxygen is in. And remember, the first thing that I want to, the second step in stoichiometry, the first part here is that I want to convert this grams to moles, because the only way I'm going to compare oxygen to carbon dioxide based on the reaction is by moles. So I'm going to set up a conversion in which I convert grams of oxygen to moles of O2. And remember, I know this conversion because I know how many grams there are in 1 mole of oxygen, and I'll look at my periodic table, and oxygen is right here, that there are 16 grams in 1 mole of oxygen, but this molecular oxygen has 2 oxygen atoms, so I take that 16 times 2, and I get 32. So there are 32 grams in 1 mole of O2. So then my grams cancel out. I'm left with moles of oxygen, and this is the point where I can do that all-important toggle point of stoichiometry, where I can convert moles of what I'm given to the moles of what I want to get to, and that's the CO2. So I'm going to convert moles of oxygen to moles of carbon dioxide. And the place where I find these numbers is going to be from my balanced equation. And so I use the numbers in the balanced equation that tells me that 3 moles of CO2 is formed when I react with 5 moles of oxygen. So it's at a ratio of 3 to 5. So that's where those numbers come from. Now that I've got moles of CO2, I'm going to convert that now to grams of carbon dioxide. And so I want moles on bottom, moles of CO2. And I do know how many grams 1 mole is because I can look at the periodic table, and carbon dioxide is made up of 1 carbon and 2 oxygens. So I'm going to take 1 carbon, which is, we'll round this to 12, plus 2 oxygens. So it's going to be 12 plus 2 times 16. So that's 32 plus 12, which is 44 grams. 44 grams are 1 mole of carbon dioxide. So that's that conversion to get me from grams to moles. I know that in 1 mole of carbon dioxide, it's 44 grams. And what I'm left with is grams of carbon dioxide on top. That's what I want, so I can stop there. I can start just calculate with my dimensional analysis. I'll take all of my top, multiply it together, all of my bottom, multiply it together. So it'd be 100 times 3 times 44, and divide that by the product of 32 times 5. I guess when I'm saying this, and I know I've done this in class too, I've been ignoring these ones because if you multiply or divide by 1, it's just that number. So that's why I'm kind of ignoring those numbers, but not necessarily mathematically. It's just the same thing. And so do this. And the answer I get is 82.5 grams of CO2. And that is, once again, another problem in stoichiometry.